What's up? I'm Vin, and today I want to go through the June 2022 Geometry Regents. So let's get started. So for question 1, we have triangle ABC, and we're told that there's a dilation being done to this triangle. And here's the points for ABC. And the image is A prime, B prime, C prime, and we're given the coordinates of A prime, which is -4, 2, which is over here. So what we have to do is we have to find the coordinates of B prime, which is going to be somewhere over here in this neighborhood. If I had to take a guess, I would say 4, 8, but I'm going to go ahead and do this, a more technical way. So what we have to do here is notice that A is the point -2, 1. And to get to A prime, we're going to be multiplying each of those values here for X and Y by some number K. So then what we do is we just set -2K, the X coordinate, equal to the X coordinate -4. And that tells us that K is going to be equal to +2. Now, if we had to, we could set 1K equal to the Y value 2, and that also tells us that K is equal to 2. So this is our constant value here that we're multiplying by. So if we want to find the coordinates of B prime in a more technical way, what we have is we have B is the point 2, 4. So now just know B prime, we're going to multiply each of these by 2, and that's going to give us 4, 8. So definitely choice 2. So for question 2, you have to know Cavalieri's principle, and we have a plane intersects the square pyramid below parallel to the base. So the base is the bottom over here, and just know a plane in geometry refers to almost like a sheet of paper. It's this flat surface here that's hitting, and we have to think that when it intersects the pyramid, what shape are we going to be staring at? Well, it's going to hit it like this here, and if we kind of draw this in and visualize this here, you could see the cross section in this case is going to be a square. So choice 2. For question 3, we have this triangle is the image of this triangle after a dilation of DE over AB centered at C. So there's a lot of stuff to process here. But for these questions with this diagram, what jumps out at me right away is that the two triangles in question here are going to be similar triangles. And the way I know this is that a dilation changes the size of a shape, but it keeps the angles intact. So when we dilate a triangle, the resulting triangle is going to be similar to the original one. And then what they have paired with this is some trig functions we have to go through. And it looks like just sine and cosine in the answer key, but the phrase SOHCAHTOA helps. That sine is the ratio of the opposite side over the hypotenuse, and cosine is the ratio of the side adjacent to the angle over the hypotenuse. So now one last thing that I'll do here is I'm going to draw these triangles out, but separate. So I have triangle ABC like this, and we'll draw the right angle over here. And then we also have the small triangle, triangle DEC. So that's what we have here. And just know all the answer choices use angle A, and angle A is in this location of the triangle here in the top left corner. So angle A and angle D are going to be congruent because in similar triangles, all the angles are congruent, the ones that are in corresponding locations. So now we just go ahead and apply all this. We're going to run through the answer choices. So sine of angle A, if I use the triangle in blue, opposite of angle A is side BC. Over the hypotenuse of this triangle in blue is AC. But notice that doesn't match what we have here for choice 1. But what I also have to consider is doing sine of angle D in this triangle, because once again, since these two right triangles are similar, that means that their sides are going to be proportional. So it doesn't matter if we set up the ratio in this one or this one. So now if we do sine of angle D, opposite of side D is side CE. Over the hypotenuse is CD. And notice right away that it matches choice 1. Now we could check the other answer choices here, but what's going to happen is we're not going to wind up with this ratio CD over CE if we were to take the cosine of angle A in this triangle, or if we were going to take the cosine of angle D in the green triangle. For question 4, we have a regular pentagon is rotated about its center, and we want to know what is the minimum number of degrees needed to carry the pentagon onto itself. So for this one here, we'll do our best to draw out a pentagon just so we could kind of visualize what's going on here. But if we're rotating it about its center, what I like to think about here is I draw a point in the center, and then I draw lines like this connecting the center to the vertices of the regular pentagon. And just know a regular polygon is a polygon where all sides and angles are equal. So the way I drew this, the pentagon, all the sides are the same and all these angles here are the same. But in order for it to carry onto itself, that means we have to rotate at an angle exactly equal to the measure of one of these central angles. Well, just know if we were to spin it all the way around, that would be 360 degrees. But we have 5 central angles here that are equal in measure. So if we just do 360 degrees divided by 5, that's going to be equal to 72 degrees. And right away, I could see that this shows up as an answer choice. But notice the question is, what is the minimum number of degrees needed to carry the pentagon onto itself? Because technically 144 degrees would do it if we spun the measure of these central angles twice. That would also work, but it's not the smallest one. This wouldn't work at all. And this one here, 72 times 5, if we spin 360 degrees, that would work, but we want the minimum. So definitely choice 1. Question 5, we have 2 congruent triangles, and we want to know which sequence of rigid motions, or which rigid motion would map triangle ABC onto triangle A prime, B prime, C prime. Well, right away I could eliminate choices 1 and 2, because if we just reflect over a single line, and notice the line has a negative slope, so the idea makes sense, but the problem is that A, if we mapped over a diagonal line like this, would right away map to something like B prime, and that wouldn't be any good for us. So we're going to have to work with a rotation here. Now, just by process of elimination, I see rotating about the origin is not going to work, because notice how much closer this triangle is to the origin than this one. So right away I see this one's out, and choice 3 is looking good. But now just to verify here that this one is definitely our answer, if we look at the point 1, 1 as the center of our rotation, you could see here that if we connect these points, we're going up 1 over 1, 2, 3, 4, 5, and then we're going up 1 over 1, 2, 3, 4, 5. So the distance from the center to A is equal to the distance from the center to A prime. And if we repeat this process for the other points here, let's say I connect B to B prime and we draw a straight line, we're passing through the center here, and we're going up 1, 2, 3, 4, 5 over 1, up 1, 2, 3, 4, 5 over 1. And then the same thing for C prime here. If we were to connect these 2 points here like this, notice we're going up 1, 2, 3, 4, 5 over 1, 2, 3, 4. So we have to go up 1, 2, 3, 4, 5 over 1, 2, 3, 4. So this center is definitely looking good. So definitely choice 3. So for question 6, the best thing we could do here is just draw this out. So we have right triangle TMR is a scalene triangle, which means none of the sides here are the same, and we have a right angle at M. And what we could do is we could just label the other sides as T and R, or the other angles as T and R like this. So now we just have to run through the answer choices. Sine of angle M. Well, right away what I see here is sine of angle M, that's sine of 90 degrees. And sine of 90 degrees is exactly equal to 1. Cosine of an acute angle is not equal to 1. The only time these would be equal would be if we had cosine of 0, but cosine of 0 wouldn't make sense for angle T. T can't be 0 degrees, so this one's out. Sine of angle R. So now we're getting to something here. And let me put some letters here just to make it easier. I'll just put ABC like this. So sine of angle R would be opposite over hypotenuse. Cosine of angle R would be adjacent over hypotenuse. And notice they told us this triangle is scalene, so none of the sides are equal to each other. So this one's out. There's no way that these would be equal to each other, since A and B are definitely not the same. Now for choice 3, we have sine of T. Sine of T, we could look opposite of T is side that we labeled with a lowercase b, and the hypotenuse is C. And is that equal to cosine of R? Adjacent to R is B over the hypotenuse C. This one is checking out, so this looks like our answer. But now just to be safe here, if we look at the last one, sine of angle T would be B over C. And if we look at cosine of angle M, well, cosine of 90 degrees is equal to 0. And since this is an actual triangle, B is not going to be 0, so this wouldn't make sense. So 4 is out, definitely choice 3. So for question 7, we have triangle AED, and then we have a straight line ABCD like this. And we're told AE is congruent to DE. So right away, when I see 2 sides of a triangle are the same, I think, okay, this is an isosceles triangle, and that means the angles across from the congruent sides are also congruent. So that means angle A and angle D are the same. But notice right away, I look in the answer choices here, and they didn't name any angles with a single letter. So now we have to sift through this a little bit. Now, this is not necessarily drawn to scale, but EB congruent to EC, that could be true, but doesn't have to be true. We're looking for one that's always true. Is AC the same as DB? Well, once again, we're not guaranteed that AB and CD are the same length. So once again, here, I cannot guarantee that this and this are the same, even though the way it's drawn, it looks like it is. But we can't guarantee that if point B were, let's say, like over here instead. Okay, then that would change everything. So that means we're going to eliminate 2. That's not necessarily true. Now, choice 3, now we're looking at angles. Angle EBA, so that's this angle over here. Is that going to be the same as angle ECD? Well, once again, if point B were drawn in a different location, like if point B were over here, then angle EBA would no longer be the same as this angle over here. So not always true, so that one's out. So right away, by process of elimination, it has to be choice 4, but let's see. Angle EAC, that's this angle over here that we already marked, has to be congruent to angle EDB, which is the angle we already marked. That has to be true by the isosceles triangle theorem, so definitely choice 4. For question 8, we have a diagram here, and we're told if the triangle is continuously rotated about side AC, the resulting figure will be. So what you have to imagine here is that this picture comes to life and starts to spin. And we can imagine here that it's going to make a shape like this. So let's do our best to draw something nice. And that's not the best drawing in the world, so let me try that again. So we have this here, and this would just be one of the cross sections. So let's say I just come out and go ahead and draw this. So we can imagine here what we have is we have a cone. And I'll go ahead and label the dimensions that this is 8 and this is 15 here. And notice the radius of this cone at the bottom is 15. So we have a cone with the radius of 15 and the height is 8 units. So choice 1. So question 9, we want to know which statement is sufficient to prove that ABCD in this diagram is a parallelogram. Now, if we go to the answer choices, angle 1 is congruent to angle 3. What that proves is that these lines here, okay, line M and line N are parallel. If we say that angle 1 and angle 3 are the same, because notice we're cut by this transversal and the corresponding angles formed are congruent. But that only proves that one pair of sides are parallel, not necessarily the other sides over here formed by line K and line L. So just one statement of congruence is not going to do it for this. If we say angle 4 and angle 7 are the same, that's going to tell us that these lines are parallel because we have congruent alternate interior angles. So once again, a parallelogram, we need both pairs of opposite sides to be parallel. But now if we look at this one, angle 2 is congruent to angle 5, so these two would prove that line K and line L are parallel if we say that this angle and this angle are the same. And then next we have angle 5 is congruent to angle 7, and that would tell us that these lines here are parallel, because once again, if we have parallel lines cut by a transversal and the corresponding angles formed are congruent, then that tells us that we have parallel lines. So now we have two pairs of parallel sides in this triangle. We have two pairs of parallel sides in this quadrilateral, so we could say here that this quadrilateral is a parallelogram. So definitely choice 3. Question 10, we want to know which transformation does not always preserve distance. And for a question like this, I always think of the transformation ahead of time, and that means that I'm looking in the answer key for a dilation. And if we look through the answer key, you could see choice 3 here. By multiplying the x by 2, that would be an operation that would not preserve distance. So definitely choice 3. Question 11, we have parallel lines here, EF and HG. And that tells me right away, with all these sides given, that we're going to be using similar triangles here, because we have these angles are congruent because they're vertical angles. And then I could say something like angle F is congruent to angle H because we have alternate interior angles formed by parallel lines in this transversal. So we have angle-angle similarity, so we can set up a proportion now. So in the small triangle, I could say 1.4x plus 3 over, and I'm going to set 5 in the denominator here. And then I have to set up the same ratio in the second triangle, making sure I use the corresponding sides. But be mindful that 1.4x plus 3 was between the single and double notch angle. So between the single and double notch angle here is this side 6.1x and then minus 6.5. And this is going to be over 12. And just remember, once again, the goal is to find the length of side HI, which is over here. So now we're just going to do the algebra. We're going to cross multiply. 5 times 6.1x is going to give us 30.5x. And then we're going to do 5 times negative 6.5, which is going to give us negative 32.5. And now this we're going to set equal to, we're going to multiply 12 by this term here. So 12 times 1.4 is going to give us 16.8, and we're going to just tack on the x here, and then we're going to have plus 36. So now what we could do is just move everything to one side. We'll move all the x terms to one side and move the constants to the other side. So when we subtract here, we could use a calculator for this, but what we could do is just borrow. We're going to have a 2 here. We're going to make this a 10, but we're going to borrow, make this a 9. We put a 1 here. And now 15 minus 8 is going to give us 7. 9 minus 6 is 3. 2 minus 1 is 1. And we have 13.7x. And now all in one step, we could add 32.5 to both sides. So we're adding 32.5 to both sides. And that tells us on the right side, we're going to have 0.5. And then we have 6 plus 2 is 8. And then 3 plus 3 is 6. So then all we have to do here is divide by 13.7. And that's going to tell us what x is. And if we do this division here, this is going to tell us that x is equal to 5. But we're not done here. What we have to do is we're going to have to plug x back in to solve for the length of hi. So this is a very distracting answer choice here. It'd be devastating if we pick that. So we have 6.1 times x equals 5, and then minus 6.5. So once again, 6.1 times 5 was 30.5, and now we're subtracting 6.5. So 0.5 minus 0.5 is 0, and then 30 minus 6 is 24. So we're going with choice 4. Question 12, we have a square pyramid and it's modeling a toy block, and we have each side of the base measures 4.5 centimeters, and we're told the height of the pyramid is 10 centimeters. So these are significant values. And we're told the density of maple. So this is very important here. The density is equal to 0.676 grams per cubic centimeter. And we want to know what is the mass of the block to the nearest tenth of a gram. So anytime I think density, density is equal to mass over volume. So if we're solving for the mass, mass is equal to density times volume. So what we have to do is we have to find the volume of this square pyramid here. And just know that the volume of a square pyramid is equal to 1/3 the area of the base times the height. So what we could do is we could say that the mass is equal to, and I'll write the density first, is 0.676 grams per cubic centimeter. And now we're going to multiply that by 1/3. The area of the base is 4.5 squared, because we're doing, it's a square base and the side lengths are 4.5. So we have 4.5 squared, and the square centimeter I'll attach at the end. And then we're multiplying that by the height, which is 10 centimeters. But remember, if I do centimeters squared when I'm squaring the base and multiply that by the centimeters and the height, centimeters squared times centimeters is going to give us cubic centimeters, which makes sense because we're talking about volume. But now notice cubic centimeters over cubic centimeters cancels. And now I could just find the mass directly, that we're going to have 0.676. We're going to be multiplying by 1/3. If I do 4.5 squared, that's going to give us 20.25. And we're multiplying this by 10. And at the end, we have grams. The rest is calculator work. So let's just type this all in. We had 0.676. And then we're multiplying by 1/3. And then next was 20.25, or I could just say 4.5 squared. But we'll just say we know what 4.5 squared is. And then we're multiplying all of that by 10. And now our final answer, we're going to have 45.63. So once again, this was 45.63, but that's going to round to the nearest tenth to 45.6, choice 1. Question 13, we have more similar triangles, but this time we have a right triangle with the right angle here, and the altitude FH is intersecting the hypotenuse at H. So this is another right angle. So with questions like this, you have 3 similar triangles, the big right triangle, and then these 2 little right triangles. So next I would label FH, the altitude is 9 units, and then EF over here is 15 units long. And we want to know the measure of EG, which is this distance all the way across here. So here I could just put an X, and once again, that's what we're looking for. So one of the things that jumps out at me right away is that we have a right triangle here, and we're missing one of the sides. So we're missing the length of side EH. So there's a few ways we could go forward with this, but my instinct is to find the length of EH. And one thing that jumps out at me right away is I think of this triangle 3, 4, 5. If I were to multiply everything by 3, then that would give me this triangle, not drawn to scale, but if I multiply every side by 3, I would have 9, 12, 15. So right away I'm looking at this and I'm saying, okay, EH is equal to 12. And now what we could do is, our next bet is to find the length of side HG, and then we could use that to add up whatever this distance, we have 12 plus whatever this distance is, that's going to give us the entire length of EG. So now I'm looking here in this triangle. And once again, this is not, I don't have to try to just eyeball this. I want to make sure I set up the proportion correctly. But one thing I could do is I could label the angles that, because we have two right angles here, let's say I call this angle here theta 1. I'm going to call this angle theta 2. And notice that we have a right angle here. So theta 1 plus theta 2 equals 90. So this is a right angle. So if this is theta 1, this would have to be theta 2, because once again, I'm saying theta 1 plus theta 2 is equal to 90 degrees. And if this is theta 2, then this would be theta 1. So I'm writing those angles in there because when I set up my next proportion, my goal is to find the length of side HG, which I'll put a Y there just to have it, simpler, so I don't have to write two letters. And now what I'm thinking of is that, let's say I set up 9 over Y. So you see in this triangle here, 9 over Y. To get to 9 over Y, I'm going from theta 2 to 90 to theta 1. So that's my thought process, that I'm going from theta 2 to the 90 degree angle to theta 1. If I walk this way, I'm going 9, and then I'm going Y. I'm going from theta 2 to the 90 to theta 1. So now I'm going to do the same thing in this triangle. From theta 2 to the 90 is going to give me 12 first. And then over, when I go from theta 2 to 90 to theta 1, I'm going to 12, and then I'm going to 9. So now we just cross multiply here. 9 times 9 is 81, and that's equal to 12 times Y. And then if we divide both sides by 12, that's going to tell us the length of HG. So this, if we do the division here, well, first up, I just think that 12 times 7 is 84, which is too much. So 12 times 6 is going to be as close as we could get. And 12 times 6 is 72, so we have a remainder of 9 over 12. So this is going to be equal to 6 3/4, which is 6.75. And now, remember, this was the length of Y. If I want to find the entire distance EG, I'm just going to add 12 plus the length of Y is 6.75. And this is going to be 18.75, which is going to match up with choice 3. Question 14, we're told all this stuff here, and we're told DE is parallel to BC. So DE is parallel to BC. And right away, I'm thinking similar triangles. So that's a very common theme for this Regents. And we want to know which statement is always true. Well, once we know that these lines are parallel, that tells us that these are not necessarily right angles, but I could say this angle here is the same as this angle here, and then this angle here is the same as this angle here. So right away, without even looking at the answer choices, I'm saying triangle ABC is similar to triangle ADE. So I see this small triangle here is similar to this big triangle because those lines are parallel. So now I just look for that in the answer key. ADE is similar to ABC is choice 2. That is always going to be true, and this is definitely our answer. Question 15 is all drawing and definition. So we're told if one exterior angle of a triangle is acute. So I would draw an acute angle, which means less than 90. And now I'm going to draw a triangle around it. So here's our triangle going around it. So you could see here that our exterior angle is acute. Well, if this angle is acute, then this angle here would have to be obtuse. So like, let's say this angle were 60. Then this angle here would have to be 120. And this triangle would have to be obtuse because one angle would have to be bigger than 90. So definitely choice 3. Question 16, given the information marked on the diagrams below, which triangles cannot always be proven congruent? So anytime I'm looking for which theorem doesn't prove triangles congruent, it's almost always the donkey theorem. ASS, which is such a bad word that I'm not even going to say it. I'm not even going to spell it, but I'll spell it backwards. So I'm looking for side-side angle, and it's looking right away like choice 4. You see how we have two sides congruent in both triangles and the angle that's not between them. See, these over here, I would have vertical angles are congruent, so I'd have angle, angle, side. So this is out. These, they share a side, so it'd be side, 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 which always proves triangles congruent. And then for this one here, we have these two sides the same. They share a side. So this is going to be side angle side congruency. So not choice 1. So definitely choice 4. Question 17, we have to know a little trigonometry, but we have this nice diagram. And ultimately, we want to find the value of x, which is the vertical drop to the base of the hill. And we're rounding to the nearest foot. So what we have is we have a right triangle, and we have one of the exterior angles. And if this angle here is 100, that means this angle here has to be 80 degrees. And if this is 90 and this is 80, this would have to be 10 degrees. So now our goal is to find x, and there's a few ways we could do this. But let's say we have this mnemonic here, SOHCAHTOA. We want to find the value of x. We could use sine or cosine, but it depends on which angle we want to use. Let's say 10 degrees is your favorite angle. Well, if you're going to use the 10 degree angle, then x is opposite of the 10 degree angle, and we're given the hypotenuse of this right triangle. So then if we're going to use the 10 degree angle, we're going to say sine of 10 degrees is equal to the side opposite, which is x, over the hypotenuse, which is 140 feet, but we'll leave the units out and we'll just look for the value of x. So now we have x times 1 is equal to 140 times sine of 10 degrees. And now we're just going to type this in the calculator. So I'm just going to switch over here to degrees. So we're writing in, we have 140. So we'll go back to the main screen here, 140 times sine of 10. And we're going to the nearest foot, which is going to give us 24 feet. So to the nearest foot, x equals 24 feet. And choice 1 is our answer. Question 19, we have these two triangles here, and we're told that they're congruent, and we need to find out which combination of rigid motions maps this triangle LET onto triangle L double prime, E double prime, T double prime. So the best way to go through this is we could just go through the answer choices one by one. So if we reflect over the y-axis, then the x-axis, the problem with that is when I reflect over the y-axis, I like to just count boxes. We go 1, 2, 3, 1, 2, 3, and that would put L prime here. But the problem with this transformation is when we go over the x-axis, it's going to throw us somewhere over here, and we're going to miss L double prime. So right away, that tells me that choice 1 is out. Now, a rotation of 180 degrees about the origin, the reason why this one is no good is that if we were to connect these points, L and L double prime, they would have to connect by straight line through the origin. But notice here, when I draw this straight line, it misses the origin. So that's how I know choice 2 is not going to be it. So this one's out. So next, we're reflecting 90 degrees counterclockwise. And there's two ways you could do that. You could just pick out a random point and draw it on the side like 2, 1. And if you rotate your paper 90 degrees, what that's going to do is it's going to make your paper look something like this. Like it would be here like this. And then your 2 would look somewhat sideways. And what that would tell you is that the point 2, 1 goes to the point negative 1, 2. So once again, if you ever forget the formula for rotating 90 degrees counterclockwise, which is negative y comma x, what you could do is just draw a point, physically turn your paper 90 degrees, and you'll be looking at this. And once you see what happened to your point, it reteaches you the rule. Because I know I have trouble memorizing these rules. So then once we have that, if we rotate 90 degrees counterclockwise, let's say we take a point like negative 1, 3. So this point here, negative 1, 3. And if we go through this transformation, the point negative 1, 3, if we rotate it 90 degrees, that's going to map it to negative 3, negative 1. And once again, I'm just following this rule. So negative 3, negative 1 would put us here. And now if we reflect over the y-axis, that's 1, 2, 3, 1, 2, 3. That's going to map us here. So this is already looking good. What I would do to really be sure is just check the other point. So this is the point negative 1. I'm sorry, going 1, 2, 3, 4, 5. So negative 5, 1. This would map us to negative 1, negative 5, which would send us down here. And then we could see if T prime is here, T double prime is a reflection over the y-axis. And now L is at negative 1, 2, 3, up 1, 2, 3, 4, 5, 6. So negative 3, 6. This would send us to the point negative 6, negative 3. So we're going 1, 2, 3, 4, 5, 6, 1, 2, 3 down here, and that would be L prime. And then if we go across the y-axis, this one definitely checks out. So this one is very wordy and there's a lot of stuff to draw. So I would just bring it to life by drawing it out. We have diameter ROQ and it's circle O. So that means the center is going to be called O. So we have ROQ and we just draw this in like this. That's a diameter. And it's going to be extended through point Q like this. and it's going to go to point P, and then tangent PA is going to be drawn. So the tangent here is not necessarily going to be drawn to scale. It's going to be drawn like this. So we'll just assume that this is a tangent. So tangent PA is drawn. And remember, a tangent line is going to be perpendicular to the radius. So this is going to form a 90-degree angle. And now we're told the measure of arc RA is 100 degrees. So that's over here. What is the measure of angle P? So there's a few ways we could go forward with this, but if this angle is 100 degrees here, this was a diameter, so that means the measure of this arc over here has to be 80 degrees. And if this is 80 degrees, what we have is this is the central angle over here, and central angles are equal to the measure of the arcs that they intercept. So this would be 80 degrees. So if this is 90 and this is 80, the measure of angle P would have to be 10 degrees because the sum of all three angles of a triangle has to equal 180. We could just check 90 plus 80 plus 10 degrees. This would make 180 degrees if we add them up. So the measure of angle P has to be 10 degrees, choice 1. Question 20, we have these 2 points and we want to find the perpendicular bisector of segment JM. So my thought process for these questions, because there's a lot of steps to writing the equation of a perpendicular bisector, is that whatever JM looks like here, so here's our segment, let's say, the perpendicular bisector goes through the midpoint and makes a 90-degree angle like this. So that tells us when we're coming up with the equation for the perpendicular bisector, one thing that we have to know is the midpoint. And let's just say I call that point P. So to find the midpoint, we would find the average of the x values. We have -5 plus 7 divided by 2. And then we have to also take the average of the y values. So we have 1 plus -9, and we're dividing that by 2 as well. So this tells us our midpoint is going to be 2 divided by 2, which is 1, that's our x, and then 1 minus 9 is -8 over 2 is -4. So this is going to be our point, and ultimately we're writing the equation of a line. A perpendicular bisector is a line, and this is the equation we're going to need. So the midpoint here represents our x1, y1. And if we look to the answer key, we have x minus x1. So we need an x minus 1 in our solution. So right away I know choice 3 and choice 1 are out because they have an x plus 1. So it has to be one of these. But then once again, what makes a perpendicular bisector unique is that it's perpendicular to the original line segment. So if we find the slope between those 2 points, we're going to do -9 minus 1. So we do the difference of the y values over the difference of the x values, where we have 7 minus -5 like this. So this would make -10 over 12, and that reduces to -5 over 6. So then what would be the slope of the perpendicular line? We take the negative reciprocal of this. So if it's negative, we change it to positive, and then we flip this to 6 over 5. So that's the last piece of the puzzle here. We're looking for the line with the slope of 6 over 5, and that's going to match up here with choice 4. Question 21, we have this wacky diagram here. We're told a bunch of stuff, and we want to find the measure of angle FHB, which is over here. So the best way to do these questions is to just start plugging in all the stuff they gave you. Measure of angle E down here is 62 degrees. We have the measure of angle C in this corner is 51 degrees. And now the other information we were given that we didn't use yet, we're told that ABCD is a parallelogram. And some stuff that helps out here is that parallelograms, opposite sides are congruent and parallel. And also angles that are opposite each other are congruent. Consecutive angles add up to 180. So right away, if this angle is 51 degrees, this angle BAD is also going to be 51 degrees. So I would just start labeling as much stuff as I can. We're also told here that EB is congruent to FB. So that's this segment here is congruent to this segment. So in this triangle, EFB, this is isosceles. So if this angle is 62, then this angle here, EFB, would also be 62 degrees. We're also told here, there's a lot going on in this question, but we're told EF is perpendicular to FH. So if EF is perpendicular to this, then this angle here is 90 degrees. So if this piece is 62, we could subtract 62 degrees from 90 degrees to find the missing piece. And if we do the subtraction here, that tells us this little angle here is going to be 28 degrees, angle BFH. So now this is starting to unravel a little bit. We have to think about what other information haven't we made use of yet. Well, what we could talk about here is this angle at the top. So this angle, we have 62 plus 62 is 124. So if we subtract that from 180, that'll tell us the measure of angle EBF. So once again, there's not like one nice way to do these questions. I just find as many angles as I can until the angle that I need is like in clear sight. So we have now, this is 56 degrees, but now we have to make use of this parallelogram again. This is 51 degrees, but consecutive angles in a parallelogram are supplementary. So that means angle ABC is going to be equal to 180 minus 51. So we do 180 minus 51, and if we work this out, this is going to work out here to, looks like, whoops, careful subtracting, 7 minus 5 is 2. So this works out to a 129 degree angle at the top. So if this whole angle is 129, and so far we have 56, now we just subtract 56 here, and this is going to work out to 73. So this angle here is 73, and now it's starting to come to a close here. So this is the final part to focus in on. Notice this triangle here, we know two angles, and we just want to find the third one. So the measure of angle BHF or FHB, we could just do 73, and careful writing there, 73 plus 28 is going to give us 101, and we're going to subtract that from 180. And when we subtract this from 180, we're going to get 79. So the measure of this angle is 79 degrees. This matches choice 1. Question 22, these questions can be a little bit tricky. You could always draw this out on the graph, but otherwise what you could do is think about it like this, that if I have point A, and then I'm going to point B, and this is not drawn to scale, but I'm going to place a point P, such that it breaks this line segment into a ratio of 2 to 3. What that means is that it's going to break this thing into, we're going to have 5 equal parts. So we have 1, 2, 3, 4, 5. So point P would be somewhere here. And the idea is, once again, that P is here, and it breaks this into a ratio of 2 to 3. So here's the 2 pieces, and there's the 3 after it. Now, the concept is, how I do this without a graph, is that we have to think that we're rising and running from A to B. So notice here that point P is 2/5 of the way from A to B. Okay, so point P is 2/5 of the way, because we broke this into 5 equal pieces. There's 2 before P and 3 after. So what that tells us, if it's 2/5 along the way, and we're starting at A, see, we start here, we go from A to B, because this is more to the left than B is, then what we're going to do is we're going to go by the X, and then we're going to go by the Y. So we have -4, that's our starting X value, plus 2/5 of whatever the difference in the X is. So from -4 to 6, if I'm going from -4 to 6, that's a jump of 10. And that's going to tell us our new X value. So if I take, this is going to work out to 10, and 2/5 of 10 is equal to 4. -4 plus 4 is equal to 0. And now I repeat this process for the Y's. So if we look at the Y value, we're starting at point A, so now we're starting at -1 for the Y. And we're going 2/5 of the way. But from -1 to 4, that's a jump of 5. So if I go from -1 to 4, that's an accumulation of 5. And 2/5 of 5 is 2. -1 plus 2 is equal to 1. So we're going to land at the point 0, 1. Choice 2 is our answer. Question 23, you could sort of do this in your head, but I'll draw it out, that what we have is a line, and we're dilating this line by a scale factor of 1/3, and this is big, centered at a point on the line. So one thing to know about a dilation is that it preserves angles, and for lines, it preserves slope. So if our point, our center of dilation, is on the line itself, when we scale it by 1/3, yes, it's going to start shrinking these points inward, but we have infinite points. So this line is going to be the same line even after the dilation here, because once again, our center is on the line. If the center was off the line, then we would have a new line, but the image and the pre-image are going to be the same, once again, because the center is on the line. So question 24, we have another diagram. We want to know the area of the shaded sector. So what we're going to do here is, we're told that we have secants and tangents, and if AB is a tangent, that means this angle is 90 degrees here. So we have a 90 degree angle here in this triangle, and we're told the measure of angle OBA over here is 36 degrees. So this is a 36 degree angle. So then I could find the measure of angle AOC if I do 90 plus 36, that's 126, and then we subtract that from 180. So we'll just go ahead and do that here. So this is going to work out to 54. So that tells us this angle here is 54 degrees, but now we have vertical angles, so that means this angle is also 54 degrees. So now some other stuff to consider here. We're told the length of OC, this part here, is equal to 10 units. And just know this is a radius, and in a circle, all radii are congruent. So if we want to find the area of just this sector, what we're going to do is find the area of the whole circle. So we have pi times the radius squared. However, we have to just take a fraction of the circle, and we're taking a 54-degree slice out of the 360 degrees total. So now we just have to simplify this a bit. So the units will cancel out, but we'll have 100 pi times 54 over 360. So what we could do here, you could use a calculator, but I'll just go ahead and say we'll divide the top and bottom here by 18, and 54 divided by 18 is 3. So we're going to have 100 pi times 3 over 360 over 18 is 20. And now 100 divided by 20 is 5, and then 5 pi times 3 is going to give us 15 pi. So our solution here is choice 4.